All right. So we talked in the previous section about the fact that all atoms of a particular element have to have the same number of protons. And because all atoms are neutral, all atoms of an element have to have the same number of electrons. But it turns out that all atoms of an individual element are not always completely identical. And the reason for that is because atoms of an element can have different numbers of different numbers of neutrons. And to get into that a little bit further, we are going to discuss here what are known as isotopes. So isotopes are atoms of the same element. Isotopes of an element have the same number of protons. They have the same number of electrons. So since they are atoms of the same element, they have the same atomic number. However, isotopes of an element have different numbers of neutrons. And because they have different numbers of neutrons, the mass numbers for isotopes of an element are different. So your isotopes have the same atomic number, but different mass numbers. Okay, so let's take a look at an example. Magnesium, okay? There are 3 isotopes that exist for magnesium. They all have 12 protons. Why? Because the only element in the periodic table with an atomic number of 12 is magnesium. And that means that all magnesium atoms have 12 protons. However, some atoms have 12 neutrons. Some have 13 neutrons. And some have 14 neutrons. Now we'll talk in a little bit about which one, in a sense, does the periodic table give you. And along with that, when you're figuring out the number of neutrons, you have to really look at the question to see if they give you any information about the mass number. If they don't, then you have no other choice but really to use the periodic table to determine the mass number for the element. But when you're looking at questions, be careful if they give you information relative to the mass number. Because then the number of neutrons that you're looking at in that particular example might not be the number that you would get from the periodic table. So a lot of times the way we write isotopes is that we write isotopes using what are known as atomic symbols. In an atomic symbol, we give the chemical symbol for the element. In the lower left, we give the atomic number. And then in the upper left, we give the mass number. So the atomic symbols for the 3 isotopes of magnesium are given on this slide. Each of them has a chemical symbol of Mg. The atomic number for each of them would have to be the same, 12, because again, That's the only element that has an atomic number of 12 is magnesium. The first one here has a mass number of 24. This is the one that has 12 protons and 12 neutrons. Remember, the mass number is the number of protons plus neutrons. 12 plus 12 is 24. This one in the middle here would be the one that has 13 neutrons. 12 plus 13 is 25. And the one over here would be the one that has 14 neutrons. 12 plus 14 is 26. Okay. Notice if you were focusing only on the periodic table, the only one that you would sort of expect is the one all the way to the left, because you would round the mass number of magnesium to 24. But there are other types of isotopes of magnesium that exist. Okay. So here are some examples, okay, of a number of subatomic particles for atoms where you use the atomic symbol to figure that out. So for oxygen with a mass number of 16 and an atomic number of 8, you would have 8 protons, 8 neutrons, and 8 electrons. The protons and electrons would come from the atomic number. And then we would, to figure out the number of neutrons, the way I would do it is I would take the mass number and subtract from that the atomic number. 16 minus 8 is 8. Phosphorus, okay. Mass number 31, atomic number of 15. 15 protons, 15 electrons. 31 minus 15 is 16. Zinc, with a mass number of 65 and an atomic number of 30. 30 protons, 30 electrons, 35 neutrons. 65 minus 30 is 35. So here's some examples of atomic symbols and how many protons, electrons, and neutrons these isotopes of these elements would have. Okay. So why is the atomic mass, which a lot of times is also referred to as the mass number, given in decimal form rather than a whole number? The reason why is that the atomic mass, or the mass number, is the weighted average of all naturally occurring isotopes of that element. It's an average of all the naturally occurring isotopes of that element. Essentially, their atomic masses and what percentage that you have of them. Now, we're not going to go through any calculations of it, but that essentially is why the atomic mass or mass number is a decimal. And when you use the periodic table to figure out the number of neutrons, the one that you figure out is usually the isotope that exists the most. So they give you the example of chlorine, which has an atomic mass or a mass number 35.45, which we would round to 35. 35 minus 17 is 18. Notice that there are 2 isotopes of chlorine. This one has 18 neutrons, this one has 20 neutrons. It's this one where this number here is closer to the actual atomic mass or mass number, that is the higher percentage. You have these 2 isotopes of chlorine that exist. You have about 75% of this one in a sample of chlorine, about 24 and a quarter of this one in a sample of chlorine. So notice how this one, where you have the higher percentage, the mass number given in this atomic symbol is closest to what the actual mass number is. So we would expect to find more of the isotope of chlorine that has 18 neutrons than compared to the one that has 20 neutrons. All right, so that's why the mass number is in decimal form. And when we use the periodic table to find the number of neutrons, it's usually the number of neutrons in the isotope that exists the most.